All right, hi everybody. So today we're just going to be talking about how we can find missing and unknown sides of right triangles using tangent. So to start off, I just wanted to do a quick review. So if you don't want to watch this part, you can for sure just go ahead and fast forward. So as a review, tangent, I'm going to write it over here just so we have it. Tangent of theta equals opposite over adjacent, also known as, in an acronym form, TOA, which also means the same thing, tangent, opposite, adjacent. Easy way to help you remember this. So what does this even mean? I kind of look at this and I'm like, oh, what the heck is this, right? So what does this mean? To help us understand this, I'm going to just start off with a basic triangle, no measurements, no numbers, no nothing. Basically, what this means is, and what we use this for, is to find unknown sides of a right triangle using a known angle. So let's say we have a triangle, it looks something like this, has a right angle, and then we have an angle. This is known as theta, also means an angle. It's just a symbol that is used. So basically what this means is, let's say we had, we knew this side and didn't know this side. We could use tangent to solve for the missing side as long as it's an opposite or adjacent side. So what does opposite or adjacent mean? Basically, everything is relative to the known angle. And it's important to understand these sides and which ones are opposite, which one's considered adjacent, which one's the hypotenuse, because you need to have the right numbers in your equations and in your ratios to get the correct answer. So the first thing that I'm going to identify for you guys is the hypotenuse. So when you're looking at a triangle, the hypotenuse is always going to be directly opposite the 90-degree angle. So in this case, it's right here. So this side, hypotenuse, no matter what, the hypotenuse is always going to be across from the 90-degree angle. Typically, the hypotenuse is always going to be the longest side. So kind of recognizing these patterns will help you. Now for tangent, we don't need to worry about the hypotenuse. So knowing where the hypotenuse is and then saying, okay, I don't need to do anything with that information when we're using tangent is really important. So then where is the opposite side? So now we're going to be looking at relative to the angle that you're using. So it doesn't matter if you're using this angle or this angle in your triangle. The opposite side is always relative to the angle that you're going to be plugging in to your tangent equation. So since this is our angle, that means that opposite to that would be this side here. So that is your opposite side. Then your adjacent side, this is where some people kind of get confused. Is it this or is it this side? Which one's the adjacent? Well, we already identified this side as the hypotenuse because it's directly across from the 90. So that means that this has to be our adjacent side. And for tangent, all we're going to be using is information from this angle and our opposite and adjacent sides. We are not going to be using any information from the hypotenuse for these equations. Okay, so now, and then just to note, I'm going to write here just as a reminder for us that when you're using tangent, this will always be an angle measurement. So you're not going to be putting a side measurement in for this spot here. Okay, so now we will get into some practice problems. And you can take a screenshot. You can rewind back and take a screenshot of that if you're still reviewing like your sides and what sides go where. Okay. So for our practice problems, all of our questions are going to be asking the question, use tangent to solve for the missing side. So all of these triangles that we're going to be doing are going to be using tangent only. So if you know Pythagorean theorem or sine, cosine, blah, 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 we're not doing that in this video. We're only using tangent to solve these triangles. Okay, so for our first practice problem, we have our triangle over here. And what I'm going to do first is I'm going to kind of run through my thought process when I'm looking at this, because I'm kind of like, oh, this is kind of a lot. Like, I don't really know what to look at. I don't really know what to look for. So the first thing that I want to do is understand, okay, we're using tangent for these problems. So what do I need to know to use tangent? I need to know my opposite and my adjacent sides. So similar to like we did before, I'm walking through this problem really detailed so that you guys understand. But over here, directly across from the 35 is our opposite side. Hopefully you guys can see that. Yep. And again, across from our 90, okay, so which side is our adjacent side? And which one's our hypotenuse? Well, like we said before, our hypotenuse is always going to be across from the 90. So that means that this side is our hypotenuse. So then that leaves this as our adjacent. Now, it's kind of self-explanatory just because, these are the only numbers that were given. But sometimes the problems can get a little complicated and might include some different information. All right, so now what? We got all these things labeled. We got all these numbers. We got an X. What do we do? Okay, so now we're going to go back to our equation and we're going to set up our ratio. So we're going to write tangent. Now, like I said before, this theta is always going to be the angle that we are using as like our reference angle. So in this case, it's 35 degrees equal to our opposite side, which is X, over our adjacent side, which is 12. So it kind of helps to have that stuff labeled already. So now, if when I was your guys' age, I would look at this and be like, well, what do I do now? What does this even mean? So what I would do is I would set this over 1 because it doesn't change the value of this. It's just a way that makes it a little bit easier to look and think about what we're doing. Now, this might be a little bit more familiar. It's just two ratios, and when you have this set up like this, and you're trying to solve for x, you can do something known as cross multiplying to solve for x. So that's what we're going to do here. So I'm going to start with the tangent. So on my calculator, I'm going to type tangent. It's important to make sure your calculator is in degree mode. And so then tangent of 35 equals, so it looks like I'm going to just write my value up here so that we don't lose it. And then you guys can see if you're getting the same thing, is 0.700207538. So that's what we got for tangent of 35. Those are the same value. And then I'm going to multiply it by 12. So, because we're cross multiplying here. So I get 8.40249. That I'm just going to leave it at that. Equals x, because 1 times x is just x. So that means that our missing side, because again, it can get kind of confusing and we might forget what we're even solving for with all the work that we're doing. Our missing side is about 8.4 units long. Normally, you'll round, well, for the next problems, we'll round to the nearest hundredths place, so the second decimal. Okay, so now we will move on to our next problem. Okay, so for our next problem, we have another triangle. It's just in a different orientation. And so again, we're going to do the same thing. I'm going to move this a little bit quicker this time around. So we're going to label our sides. So again, across from the 90 will be our hypotenuse. We're not worried about our hypotenuse because that has nothing to do with our tangent formula. Now we need to figure out what is our opposite side. That would be opposite from the angle that we are plugging into our tangent equation. So this would then be our opposite side, opposite the angle. So a way that you can think of that. So then our final side would be our adjacent side. Okay, so then how we're going to set this up using our tangent equation and ratio. So tangent of the angle that we know, which is 50, and the angle that all of our stuff is being based off of, is set equal to our opposite side, which is x again, over our adjacent side, which is 22. Again, I'm going to set this over 1 so that I get 2 ratios. It's way easier for me to look at, and it doesn't change the value of tangent. And then I'm going to do cross multiplying. So in my calculator, I'm going to put tangent of 50, and that gets me a value of 1.1917536, we'll say. So these are the same values. And we'll multiply that by 22, and we'll get 26.22. Now, this is what it looks like. This is the actual value, but I'm rounding it, again, like I said, to the nearest hundredths place. So since we have an 8 in the thousandths place, I'm rounding the 2 up. Equals 1 times x, which is just x. And we don't have to do any more work. That means that our missing side is 26.22 units long. Our picture doesn't really reflect that. So if I were to redraw this triangle, now knowing what the missing side was, I would make this side longer than this side. But it's not, you're solving for a missing side, so you don't know 100% what it's going to be. All right, then we'll do another one. Okay, for our third problem, actually, we're gonna, another triangle that's in a different orientation, doesn't change the process, it's still the same thing. So I'm gonna start by labeling the sides. So this is our hypotenuse again, across from the 90. Now I need my opposite side. So 81 is the angle that we're basing it off of because it's an unknown angle. So that means that this is our opposite. And then our final one is our adjacent side. So then we'll set up our ratio again. So tangent of our known angle, which is 81 degrees, equals our opposite, which is 16, which is different. We don't have the X on the top this time, which does not change it. It's just the way that the angle placement ended up being, and that's just what ended up being opposite. As long as you have these sides identified correctly, you will get the answer that you need to get. So then our adjacent is X, again, putting this over 1, and then cross multiplying accordingly. Now this one is a little bit different because we're doing tangent of 81 and we're multiplying that with X. So this is where you're going to want to write this down really good and write down your steps. So 6.313 times X. So X equals 16 times 1, which is 16. So now we have an algebraic equation. So you need to get X by itself. So how do you do that? All right. Well, to undo multiplication, we do division. So we're going to divide both sides by the 6.313752. So we get our giant 1 over here. So it cancels it out, but it really just makes a giant 1. So then we get X equals 16 divided by 6.313752. So then 2.53 units long, which you can't see that, so I'm going to write it up here. This is our solution. X equals 2.53 would then be our solution. Again, our triangle doesn't really reflect that, so if I were to redraw it, I'd make this way shorter and it would look a lot different. All right, we'll do one more problem. For our last problem, this is a 78. Hold on, let me rewrite that so that you guys can read it. So 78. Okay, quickly identify. So we know that across from our 90 is our hypotenuse. We know 78 is our angle, so we're going to base all of our other stuff off of the 78. So our opposite the 78, that means this is our opposite, and then our final side is the adjacent. And then we can set up our ratio. So tangent of our known angle that we're using, which is 78, not 780, 78 degrees, is equal to our opposite, which is 12, and our adjacent, which is x. Set this over 1 because it doesn't change the value, but makes it a little bit less intimidating to solve. And then go ahead and cross multiply. So tangent of 78 gets us 4.704630, we'll say. Timesing that by x. So this is this. So I'll just, how do I do this? These are the same values here. Equals 12 times 1, which is 12. So we want to get x by itself. I'm going to just move this up a little. So we're going to divide both sides by the 4.704630. Both sides. So this creates our giant 1, essentially canceling it out. And we get x by itself. And then we divide 12 divided by 4.704630, and we get 2.55 as our final side length for right here. So if you guys have any questions about tangent, or you want a part 2 video on just practice problems, let me know in the comments down below. And if you have any additional recommendations or videos that you want to see, let me know. Pythagorean theorem, sine, cosine, those are all going to be up next. And I look forward to seeing you in the next math video. Bye.